Good morning, everybody. So, in today's lecture, we will discuss about the Buckingham Pi theorem, which is used for solving the complex problems using dimensional analysis. In the previous class, first we discussed about what is the use of dimensional analysis, what do you mean by dimensional homogeneity, and then what are the dimensional formulae for various parameters or variables. Then we have gone into methods of dimensional analysis. The methods are Rayleigh's method, Buckingham Pi method. In the Rayleigh's method, we can solve the problems easily if the number of variables are 4 or below 4. If the number of variables are crossing 4, then the solution becomes tedious, difficult. And that's why the second method, the Buckingham Pi method, which is easier, simple, and can be used for any number of variables. So in the Rayleigh's method, we have solved the problems taking the 4 variables, and I showed why the Rayleigh's method becomes difficult if the number of variables are more than 4. The reason being, we have fundamental dimensions, mass, length, and time. So we have only 3 equations. With the 3 equations, we can solve 3 variables easily. One more variable we can without much difficulty. But if the number of variables are increasing and the number of equations available are limited to only 3, then the method becomes cumbersome. The method becomes tedious. The method becomes difficult. So if the number of variables are more, then Buckingham Pi method is being adopted, followed, and taken up for dimensional analysis. So in today's lecture, we talk about and discuss about the Buckingham Pi method, which is damn simple. Absolutely no complications in this method. Very simple method, straightforward method. And I will take you to that method. So in today's class, we are discussing about the Buckingham Pi method. Buckingham Pi method. What it states, if there are n variables, if there are n variables in a physical phenomena, if there are n variables in a physical phenomena, and if these variables contain m fundamental dimensions, then the variables are arranged. Then the variables are arranged into n minus m dimensionless terms. Each term is called pi term. If there are n variables, please note that in a physical phenomena, and all these n variables contain m fundamental dimensions. Now we are arranging this into the whole problem is being converted into n minus m dimensionless terms, and each dimensionless term is called a pi term. Now you all know that what are the m fundamental dimensions? M is always equal to 3. Why? Because the fundamental dimensions are mass, length, and time. These three only. Number of variables may change, but number of fundamental dimensions m is 3. For example, in a problem, there are 6 variables, all dependent and independent variables put together, there are 6 variables. That means if there are 6 variables in a physical phenomena, and if these variables contain the mass, length, and time, 3 fundamental dimensions, then the variables are arranged into n minus m, 6 minus 3 dimensionless terms. That means there will be 3 pi terms, pi 1, pi 2, pi 3. That is what the statement of Buckingham pi theorem states, right? For example, let x1, x2, x3, x4, like that, xn are variables involved in a physical phenomena, in a physical phenomena, right? Now, in the x1, we call it as dependent variable. So now we can write this problem as x1 is a function of x2, x3, so on, xn. Or in other words, the same thing can be written as function of x1, x2, x3, xn is equal to 0. Right? This equation is dimensionally homogeneous. This equation is dimensionally homogeneous. Now, what we are going to do actually, if these are contain n variables, now we can see 1, 2, 3 n variables. Now, basically, if there are m fundamental quantities, mass, length, and time, if there are m fundamental, m is equal to 3 always, m fundamental quantities, according to Buckingham pi theorem, which we explained above, Buckingham pi theorem, according to Buckingham pi theorem. Now, basically, the above equation, this means this equation can be written, this equation can be written in the form of basically n minus m pi. The above equation, the above equation can be written in terms of n minus m dimensionless groups, or pi terms, whatever it is. Each pi term is each dimensionless group. So that means the same problem can be represented as pi 1, pi 2, pi into n by n minus m. So this the same problem, the previous that what I call it as, if you take it, this can be written in terms of this, right? Now each pi term is dimensionless and is independent of the system. It's a dimensionless. That means it has no units. It is independent of the system. Now, please note that division or multiplication by a constant does not change the character, does not change the character, does not change the character of pi term, right? Each pi term contain m plus 1 variables. In short, 3 plus 1, 4 variables. Next, out of the m plus 1 variables, that is 4 variables, 3 variables are 3 variables means actually m variables are repeating variables. These repeating variables, these 3 variables repeat in all pi terms. For example, in the above problem where we mentioned x1, x2, x3, for example, xn are variables. I mentioned x1 is dependent variable, whereas these are all remaining are independent variables, right? Suppose now for the repeating variables, x2, x3, x4 are chosen. How to choose repeating variables? We will explain a little bit later. But now if I take it, each pi term, because we mentioned if suppose the how many pi terms will be there as per the things, the number of pi terms are basically pi 1, pi 2, pi n minus m. These are the number of pi terms actually. So in that each pi term, if I take it, pi 1 is equal to can be written as x2. These are the repeating variables, x2 to the power of a1, x3 to the power of b1, x3 to the power of c1 into basically the remaining variables you can write. Pi 2 is equal to x2 to the power of a2, x3 to the power of b2, x3 to the power of c2 into the remaining x2, 3, 4. Suppose x5. Like that, if you go on writing pi 3 is equal to x2 to the power of a3, x3 to the power of b3, x4 to the power of c3 into x6. Like that, you go on writing basically each pi term. So pi n minus 1 is equal to x2 to the power of, for example, a n minus m, right? Then x3 to the power of bn minus m, x4 to the power of cn minus m, in last pi term is xn. So like that we can write. But what is important for you to note down is each pi term consists of basically 3 variables, same, and these are called as repeating variables. So that means in each pi term, there will be one variable extra. Each pi term consists of each pi term we mentioned actually each pi term if you take it, how many are there? 3 plus 1, 4 variables are there. Out of which 4, 3 are same. So this you should remember, right? And now what we should do is each equation is solved by the principle of dimensional homogeneity and values of A1, B1, C1, A2, B2, C2, like that and so on calculated, right? Now these are substituted in each pi term. These are substituted in each pi term and pi terms are obtained. Right? And the final equation is pi 1 is equal to function of pi 2, pi 3, pi n minus m. Right? That's it completed. So once again, I repeat it. Actually, if there are n variables in a physical phenomena, and these n variables can be represented by m fundamental dimensions, right? Now, according to Buckingham pi theorem, this problem can be expressed in terms of n minus m dimensionless terms. Each dimensionless term is called a pi term. So now if there are, for example, what do you mean by n? N is the total number of variables in a problem. And what is m? M is number of fundamental dimensions, that is mass, length, time, 3. So in any problem, if you take it, the total number of pi terms is equal to n minus 3. That is the first thing, right? Next, each pi term, when you are evaluating it, kindly remember each pi term consists of 4 variables, that is m plus 1 variables, that is 4 variables. Out of these 4 variables, 3 will be repeating in all the pi terms. Only there will be one extra variable will be there. Now next, after writing each pi term basically, then assuming that means we take it granted that each equation is dimensionally homogeneous and find out what are the exponent values. Once the exponent values are found out, each pi term is determined. Now arrange the pi terms actually at the end to get the solution. So this is the problem. But out of the entire thing here, the main important point is how to select the method of selecting repeating variables. Method of selecting repeating variables. How to select repeating variables. First thing is, please remember, as far as possible, dependent variable, dependent variable shall not be selected as repeating variable. So first rule out this. In the given problem, what is the dependent variable? That problem, once you read, you can understand in 1 second what is the dependent variable. So eliminate that. So in the repeating variables 3, that is not there at all. That is first thing actually. Second thing is the repeating variable should be such that one is basically what you call it as a geometric property. Geometric property. Geometric property means what? You can take length, you can take diameter, you can take height. So one of this can be taken as one repeating variable, and one is flow property. Flow property means what? Velocity, you can take it. Acceleration, you can take it. So this is second point. And third repeating variable is one is fluid property. Fluid property, generally fluid property means viscosity is one, mass density is one, then specific weight is one. Out of the three common, these are all common things actually. So now you remember the out of the three selecting variables, you select one from the geometric property, one from flow property, one from fluid property. So if you choose like that, then naturally you can solve the problem very easily. That is the first thing actually. Next, third point is no two repeating variables should be same. No two repeating variables should have same dimensions. That means you cannot take L and LD as two repeating variables. L and D is not permitted actually, because L and D have the same dimensions. Or you cannot take D and H as two repeating variables. No. Out of LDH, only one you should select. Similarly, you cannot take acceleration and acceleration due to gravity, because both dimensions are same. You cannot take like that. You cannot take any two variables in such a way that their dimensions are same. So that is the next condition that you should remember. Fourth thing is all these repeating variables put together, all the repeating variables together should have all dimensions. That meaning is that the total together, every variable may not have all the dimensions. All the dimensions I mean by mass, length, time. For example, every repeating variable need not have all mlt together, right? But if I take all the three together, three repeating variables, if I write the dimensional formula, they must contain totally, basically mass should be there, length should be there, time should be there. Basically out of the total, it is not individual, I am telling again. Put together, all repeating variables together should contain all the variables. That means you cannot take in such a way D, for example, right? You can V, for example, V and D you have taken. The third variable should because in D mass is not there, time is not there. In velocity, if you take it, mass is not there, L and time is there. So now in the two variables you have covered length and time, but the third variable, whichever you are choosing, must contain mass also. So that means then only three repeating variables put together, they will have mass, length, time. So this is the one more thing point you should remember. Once again, I repeat, the repeating variables should be such that actually first thing is remove the dependent variable from the list actually. That is first thing. Second thing is actually choose the three such that one is a geometric property, one is a flow property, and one is a fluid property. Then third, don't select in such a way that two repeating variables have the same dimensions. Then fourth, actually, all repeating variables put together, they must contain all three fundamental dimensions, M, L, T. That is one. Which are the general combination, if I take it in problems, when we are doing it, by experience, I am telling people will choose diameter, velocity, mass density. This is one combination people will choose. Similarly, L, V, rho. This is also one more combination. The other combination, one more combination is, for example, L V mu. This is also one more combination. So another combination is, for example, it is D basically V mu. So this is also another combination. This is only general. I am telling, need not be always same. I am telling that based on the number of problems which we have solved previously, we are coming to a conclusion slowly. Because this is a geometric property, this is a flow property, this is a fluid property. This is geometric property, flow property, fluid property. Geometric property, flow property, fluid property. Like that, I have chosen actually. So now let us, unless you do the problems, you don't understand in detail about this method. But again, I am repeating that if you want to solve a problem in dimensional analysis, first basically learn the dimensional formula for each of the variable which you come across in fluid mechanics. So open the textbooks of Modi and Seth or Bansal, and then they have written in all the dimensional formulae in one single page in the second page of the dimensional analysis chapter. So please note that. That means don't muck up. Don't try first actually. What are the geometric properties? First one. What are the kinematic variables? What are the basically the dynamic variables? Take them and write the dimensional formula. Practice the dimensional formula 3 4 times. Once the dimensional formula you are aware of fully, right? If you can do dimensional formula fast, actually these problems are almost nothing. Actually don't take any time. Only thing is procedural. But dimensional formula, if it goes wrong, the whole solution is of waste actually. So now let me take into the problem for you to understand more about this particular thing. For example, the resistance R of a supersonic plane during flight can be considered as dependent on the length of aircraft L, velocity V, air viscosity mu, density rho, and bulk modulus K. Express the functional relationship between these variables, and resistance force. So now if you see how many number of variables are there, R is one variable, the resistance is nothing but it is a force and it is dependent. So that means the dependent variable is R basically, right? Then what are the other variables basically during length? The first one is aircraft length, velocity, viscosity, density, bulk modulus K. So now if I take what is the step one for me? First dimensions writing. First dimensions writing, what are the variables I have taken? For example, R. R is what I mentioned actually, it is force. Force is nothing but mass into acceleration. Mass is m. Acceleration is LT minus 2 basically. This is first one. Second one is aircraft length. Aircraft length is dimensions is L. Third one is the velocity. Velocity is LT minus 1. That means it is distance divided by time. Then the next one he has mentioned is air viscosity. Air viscosity is mu. Mu is equal to, basically, if you calculate it, ml minus 1 t minus 1. Please try this also once. Then afterwards rho. Rho is mass by volume. Mass by volume means ml minus 3. Then bulk modulus of elasticity. Bulk modulus of elasticity is m l minus 1 t minus 2. So these are the things actually. It's only bulk modulus means stress by strain. Strain, there are no units. Only thing is the stress unit. Stress unit is force by area. Force is mlt minus 2 divided by area L square. So it becomes ml minus 1 t minus 2. So this is your first step, any problem. So first write the variables and write the dimensional formula. Next, what is step 2 actually? Step 2, my job is find out how many number of pi terms are there. That is my next job. Number of pi terms, basically. This is the thing. So now how many variables are there? Total number of variables, if I take it, total number of variables, total number of variables, how many, if I take it here, the variables, it is, one is r, the second one is length, the third one is velocity, fourth one is viscosity, then mass density, then k. So if you take it, how many variables are there? Total 6 variables are there. And number of dimensions are how many? Number of fundamental dimensions, number of fundamental dimensions, fundamental dimensions, how many actually we have? Mass, length and time, 3. So how many pi terms will be there? According to Buckingham pi theorem, the number of pi terms is equal to 6 minus 3, 3. So the equation can be expressed actually as f of pi 1, pi 2, pi 3 is equal to 0. Right, this is the now step 3 over. Then step, let us go into step 3. What is step 3 for me? Now my job is actually each pattern to evaluate. Before going to each pattern to evaluate, now I have to choose repeating variables. Repeating variables. Repeating variables, basically I have to choose. Now repeating variables, how I have to choose? One I mentioned, as in the problem given, one I want to take geometric property. Out of all the properties, if you take it, there is only one geometric property, that is L. And similarly, one kinematic property I want to take it, that is basically V. Whereas the fluid property, if I take it, how many fluid properties are there here? If I see, one is mu is there, rho is there actually, mu, rho, these are the two that we have actually in this problem. So mu, rho, out of this one I have to choose it. So if I have to choose, then basically out of them one, if you have to choose mu, r I can choose, or rho I can choose. So let me take rho. Basically there is no, you can choose mu also, but I have chosen only rho. So this is now one geometric property, one kinematic property or flow property, one fluid property. The fluid properties they have given are basically rho they have given, and mu. Out of these two, only one I have to choose. Now we select it. If all the three repeating variables, L contains, the first one contains L, second one LT minus 1, the third one is ML minus 3. So all put together they contain mass, length, time. So there is no problem at all. No two repeating variables have the same dimensions. Now depend, I have not taken the dependent variable, which is the resistance force. I have not taken as as the repeating variable. So I followed all the conditions of the repeating variables. So this is the next one actually. Then coming to the step 4, if I take it, now I will take the pi terms, how to write. Each pi term contains actually, I mentioned actually how many variables will be there in each pi term contains m plus 1, that is equal to 3 plus 1, that is 4 variables. Out of these 4 variables, 3 are repeating. Those 3 are what actually? L, V rho. These three are repeating in each term. Now, if I write what is pi 1 is equal to, for example, pi 1 is equal to L to the power of basically A1, that is first thing, into V to the power of B1, rho to the power of C1, into what are the remaining variables? I have already taken here three. What are the remaining three variables? One is resistance. This is one, right? Next, what is pi 2 is equal to again L to the power of A2, then V to the power of B2, rho to the power of C2, into what are the other remaining variables? One is mu, right? What then pi 3 is equal to L to the power of A3, V to the power of B3, rho to the power of C3, and what is the last variable that is remaining? Bulk modulus. So these are the pi terms. So writing this is next step actually. So now what I have to do in step 5, each pi term you take it, and taking it by the principle of dimensional homogeneity, each pi term is solved. Each pi term is solved by the principle of dimensional homogeneity. Homogeneity. Now, first pi term I will take it. Pi 1 is equal to, right? L to the power of A1, V to the power of B1, rho to the power of C1 into R. Already dimensions we have written above. So I bring it here, each one of them. Pi doesn't have any dimensions. Pi term doesn't have any dimensions. So pi, I can write it as M0, L0, T0, because it does not have any dimensions actually. So this is left hand side. L dimensions, we know it. L to the power of A1. Velocity Lt minus 1, you know it, to the power of B1. And then rho M L minus 3 whole to the power of C1. And the force, it is ML T minus 2. Like this, you must get actually directly what are the dimensional formulas. Now what I need to do it actually equating powers of M L T on both sides. If I equate the powers of MLT on both sides, then basically you can find out first powers of M. Powers of M on LHS, and right, powers of M on LHS is what? 0 is equal to, here there is no M, here there is no M second term, third one is only, so that means actually here it is 1, that means C1, 1 to the power of C1, C1, and one more is there, plus basically here it is 1. This is the first thing. So if this is the thing, then C1 is equal to minus 1 over. Similarly, powers of L, if I take it, powers of L, I will take it what here, 0 on the left hand side is equal to A1, fine, then plus B1, because here also 1, minus 3C1, right, plus 1, that is over. So that means this is the second. Powers of T also I will make, left hand side is 0 is equal to, here no T, second minus B1, here no, here minus 2 is already 0. So if I solve this, actually minus B1 is equal to 2, or B1 is equal to minus 2, first pi term. So now if I substitute A1 is equal, A1, B1 is how much? Minus 2. What is 3? Minus 3C1, minus minus plus, plus 3 plus 1 is equal to 0. So what is A1 is equal to, if I solve A1 is equal to, again it is minus 2. Therefore, now if I substitute in the term pi 1 is equal to how much it is coming? L to the power of a1. So L to the power of minus 2. V to the power of what actually? V to the power of b1. B1 is what? Minus 2 again. Rho to the power of what? Minus c. C1 minus 1. So this is what we are getting. And last one is the other variable. So now if I see it, how I can write? It is R divided by, because rho L square V square. Check it. Am I right? Because all minus minus, so I have taken into the denominator. So this is first pi term. Similarly, you solve for the other pi terms also. Basically, for the next pi term, if I take it the same way, you take it for all the other things also. Pi 2 also, if you take it, pi 2 is equal to again L to the power of a2, V to the power of b2, then again rho to the power of C2 into the last variable. We can write it as is, we can write mu, right? So dimensions, if I write m0, l0, t0, that is left hand side, is equal to L to the power of a2, lt minus 1 to the power of b2, and rho is ml minus 3 to the power of c2, and this is m L minus 1 T minus 1. So this is it. Now equating, this equation is dimensionally homogeneous. So equating powers of M, right? Left hand side is 0. Right hand side is only here it is C2 and here plus 1. Or therefore, if I take it, C2 is equal to minus 1. And if you take it powers of L, if I take it, 0 is equal to, it is A2, right? Plus B2, right? Minus 3C2, right? Minus 1. So this is second. Powers of T also you do it. T is minus 0, minus B2, right? Minus 1. So therefore, B2 is equal to, basically, if you solve it, B2 is also equal to minus 1, minus 1. Similarly, if you substitute a2 minus 1, minus of minus plus 3, minus 1 is equal to 0. So that means a2 plus 1 is equal to 0. Therefore, a2 is equal to basically minus. So this is the second one. A2, B2, C2. Therefore, pi 2 is equal to, for example, if you take it, then what is happening? A2, that means L to the power of minus 1, V to the power of minus 1, then rho to the power of minus 1 into mu. So this pi term can be written as mu by rho VL. So this is second pi term. Similarly, if you solve the third pi term also in this equation, if you solve the third pi term also, then naturally you just go ahead with the problem actually how to take it. The third thing also, if you solve it, then naturally we are going to get the third one in the same way, in the same way, solve the third pi term, third pi term also, and you get pi 3 is equal to, if you get pi 3 it will k by rho v square. This is how you will get. So now what are the pi terms which we got? Then pi 1 is r by rho l square v square. This is first pi term. Second pi term is mu by rho vl. Third pi term is k by rho v square. This is function. is equal to 0, right? Or if I take it, R by rho L square V square is a function of mu by rho VL K by rho V square, or R is a rho L square V square into function of mu by rho VL K by rho V square. This is the problem. So here I stop this lecture and we take up another problem in our next lecture. Meanwhile, I have given you two problems to you in the sense that how to write the dimensional formula for any of the variable. That is one of the most important thing. If then again the method actually. So with this, we will stop the lecture here, and then again we will take up one more problem in the next lecture. Because in this dimension analysis, the general thing is they will ask you to solve the problem. So you need to have the real clear cut. The crux of the problem is how to select the repeating variables. Second crux of the problem is knowing the dimensional formulae for each of the variable. They accept this too. There is nothing difficult in this chapter actually.
Like, share, and subscribe. Hit the bell icon for more updates.